Well, hello and good evening, everyone. Welcome to another episode with your girl, Audrey Codner from ACG Math Tutoring. So, I'm hella tired. But you know what? I did promise that I was going to be on here, so I like to keep my promises. So, what we are working on this time, we're looking at the properties of logs. So, some of this, some parts of it may be shown in some, definitely SAT, ACT, might creep up on maybe not the GED, but it might creep up on what's it called, the ASVAB and the ACCUPLACER. So, otherwise, or you might have this currently in your classroom. So, before we get started on anything, if you like all my replays, if you're here for the live, that's awesome. I'm glad that you are here, but I also need your help. So, hey, don't just sit here and keep taking on this free information. Let's give back, all right? So there's a couple ways that you can give back. One, you can go on Google and my ACG Math Tutoring. Go on there and put a nice little review for Google Business. Or also you can subscribe to my YouTube channel, which is Audrey Codner ACG Math Tutoring. That's where I put a lot of the replays. I put yesterday's replay up there. So if you need to take a look at the central angles or the inscribed angles, all that stuff is there as well. All right. So if you give back, that would be great. Also, if you like the notebooks that I'm dealing with, I designed this notebook especially for math. So if you are interested in having your own math notebook, please do not hesitate. Go to my website. Go ahead, click the link, which is acgmathtutoring.com. And you can click the link where it says Ultimate Math Notebook to get your own copy. All right, back to our business. Welcome, everyone, coming on in. So let's do a quick little review before we get into it. So when we have x to the 8th times x to the 7th. When we are multiplying, okay, we are basically doing what with the exponents? We are adding the exponents. So when they have the same base and you are multiplying, you're going to still keep that x as your base, but then you're adding your exponents, which will be to the 15th. So my answer for the first one is x to the 15th. Okay, there is a meaning or a method to this madness. Now, if I slide over to the next one, we have m to the 5th, n to the 2nd, over m to the 2nd, n to the 9th. So I noticed that when you are dividing, you are subtracting the exponents. So you want to go with the same base, which my m's, I'm going to subtract my exponents. So 5 minus 2, that gives me 3. So that means I have m to the 3rd. And then for the n's, I have 2 minus 9, which gives me a negative 7. So, as we've mentioned multiple times, and plus a lot of people have mentioned as well, when you have a negative exponent, you don't want to ever leave your answer with a negative exponent. This is telling me that I'm looking at a number that is a little bit lower, more like a fraction. So in order for me to change just the one with the negative exponent, which is just the n, that means this n to the negative 7 needs to drop into the denominator. So right now, everything is basically in the numerator per se, because I can really say it's over 1. So this is what's going to happen. Your m cubed is going to stay in the numerator because it has a positive exponent, but your denominator is now going to change to a positive 7. By dropping it down into the denominator, you're making yourself negate or making you change that negative exponent to a positive exponent. Because if you think about it, you have two n's up here, like n times n. Down here, you have n times 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 n down in the denominator. If I were to do canceling out, I have 7 n's left over, but they're going to be in the denominator. So this is your answer for that situation. Okay. All right. So now, last but not least, we have g to the 4th power raised to the 11th. So this is saying that I am taking this g to the 4th and I'm multiplying g to the 4th to itself 11 times. Now, I'm not going to do that individually because that is crazy. So what you can do is when you have an exponent being raised to an exponent, basically being separated by a parenthesis, you are actually going to multiply the exponents. So 4 raised to the 11th, that gives me 44. So I would have to write g 44 times, okay? So when I have a power being raised to a power, almost like being separated by a parenthesis, you want to multiply the exponents. In comparison to when I just multiply, I'm going to add the exponents. Do we see the difference here? Okay, so that's just like a quick little review. All right, good job. Hey, Sue. Let's see who else is here. We got Ashley here. We have Carson. Hello, Carson. Yep, you're right. G to the 44th. Hello, everyone that popped in and popped out and popped back in again. Like my knees on a Saturday night. Okay. So, with this review, we need to keep in mind, because now we're going to go into the properties of logs. So go ahead, write these down, take a quick pick, do what you need to do, because this is vital. So I'm going to show you the properties first, and then I'm going to show you the rules, like how we're going to apply it. So, hey, Nicole. So here we are. We have our logs, so we were talking about that yesterday. Remember, logs and exponents, they're basically inverses of each other. So we have a log with a base of b, gave us a result of 1, that's going to equal 0. Now, if we think about it, and I'm going to put it over here. So if we have our log, I'm going to slide over for a second. If we have our log with a base of b of 1 equals 0. If I change that from a log to an exponential, this is exactly what it would look like. I would have my base. My exponent is always what is after the equal sign, and it's going to equal the result, which is 1. So we know that anything raised to the 0 power is going to equal 1. So if I want to know that log base b of 1 is going to equal 0, okay? Now the next one, I'm going to try to change different colors so it'll be easy for you to read. The next one gives me my log base b of b equals 1. If I try to translate this as an exponent, let me zoom in a little bit. I have my base of b raised to my exponent, which is 1, and that's going to equal b. Okay? Because anything raised to the first power is going to be itself. So if I notice that I have a log and I know the base of the log and also the result is exactly the same, this could be a 3, that could be a 3. This could be 7, this could be a 7. my result or my answer will always be 1. Okay, always be 1. Needs help with 6th grade math homework. Help! Okay. I was like, well, I'm sorry, Jesus. Well, didn't you invent this? No, I'm just kidding. All right. Well, I'll see what I can do because I don't know how much life I have in me. So we'll talk to you after this if you don't mind. I think that's Nada. Please correct me. All right. So not a problem. So if we have the log of b, result of b being raised to the x. Okay. Now, my answer for this is going to be x, because this is what's happening. We have my base of b being raised to the x power. Okay. Is going to equal b to the x. Okay, so when we have the exact same notion, they're going to be equal to each other. So basically, this is a base, this is a base. And if the bases are exactly the same, they're going to basically cancel out. And then what's left over? What's left over is going to be your x. So we're basically saying that both sides, if I do it, change it from a log to an exponential, they're going to be exactly the same. Okay, they're going to be exactly the same. So if you ever see it like this, with a base being the result of a base being raised to an exponent, if they have the same bases, cancel those bad boys out. Your answer is going to be whatever the exponent is. Okay. And lastly, if they give you b as the base, and they said, okay, your exponent is going to be the log base b of x. If they give it to you like this, it's basically algebra 2. Okay. Okay, thank you, Nadia. So if we have a base b of b, both of them are bases, and both of those bases are exactly the same, boom, they cancel out. Okay, so we're looking at basically saying, if I may, it looks like it's going to be our log base b of x. It's going to equal, our log base b of x. Okay, so this is our reasoning. This is our reasoning. So these are the properties. Okay, so these are those properties that you really need to instill, because a lot of it is just basically almost like a little shortcut. So let's look at a couple examples before I get into the main properties of logs. Okay. So if I say, actually, let's get with the rules. So let me swing on over here. Again, want to take a screenshot? Take a screenshot. Okay, so we have those little bit of gems. But then we have the rules. We have the rules of multiplication. We have the rules of division. We have the rules of powers. So if we take a look, one step at a time. When we're multiplying, this is when you're starting to do the expansion and the condensing. Okay, I'm going to get right to it. So it's almost like when you go into, I don't know, some kind of store. It could be fashion, it could be shoes, it could be clothing, whatever it is. And you want to get a different look. It's still you, but you're just changing your outfits. Maybe changing the color of the top, changing the color of the pants, maybe changing the color of the shoes. But no matter what, the person that walked into that store is still the same person that walks out. You just have like a new look. Same thing is happening when you are condensing and when you are expanding. Condensing, you're making it smaller. Expanding, you're making it bigger. So when you do the multiplication, you're basically adding, okay, your logs together. So if I have the log base b of u plus the log base b of v, anytime I see that addition, I'm not adding these things together. I'm going to take that u and that v, and I'm going to multiply them together. Notice the log base b stays exactly the same throughout the whole process. So here's an example that I have. If I have log of 5, log base 5 of 2x, 2x means 2 times x. So I want to separate that 2x into two different products. One's going to have the 2 in it, and the other one's going to have the x in it. So I'm doing log base 5 of 2 plus log base 5 of x. So I took this product and I split it into its own logs and separate it with a plus sign. We're going to be doing a lot more examples, so you'll see what I'm talking about. Okay, so right now, either write it down or reflect on it. Okay, so the next one, the quotient rule. So quotient is very similar to what I was doing. Let me slide it up. Very similar to what I was doing when it was exponents. So when I'm dividing, I'm subtracting the exponents. Now, when it comes to logs, when I'm dividing, I'm subtracting the logs. So think of it this way. If I have my log base 7 of g over h, so that's the division, I'm going to split this division into two separate logs. Always start with the numerator. So now I got log base 7g minus log base 7h. So I basically took the g and the h and gave them their own logs. Okay, so that's the quotient rule. Product rule, when you're multiplying, you're going to add. Quotient rule, when you are dividing, you're going to subtract. And last but not least is the power rule. So now the power rule, it's saying that if I have an exponent, which we did, that exponent is now going to go to the front. Let's see if I can use this one. Now it's going to jump all the way to the front of your log. So it's going to be a coefficient. So you see how it started as an exponent and now that n is in front of your log? So let me show you an example. We have log base 2 of 4 raised to the 5th. So we took that 5 and we moved it to the front of your log. So now it's the coefficient of that log. So then you have log base 2 of 4. So 5 times the log base 2 of 4. And this is multiplication. So if you're wondering, so you can say 5 times log base 2 of 4, or you can say 5 log base of 2 of 4. Okay? All right. So I'm going to pause for a second. Let's see what people are talking about. Things just keep flashing over here. All right. So, okay, we got that. This isn't calculus, so logs, the bane of my existence. Where was this 2 weeks ago on my FYP? I don't know. Okay, I learned this in AP Pre-Calc. Good. Could we use some examples from my spring break packet? I would love to if I got that ahead of time. All right, so we got another people with a connection. They're in AP Pre-Calc as well. We still haven't gotten into Unit 3. Okay, might be cooked. Okay, I just took a test today, actually. All right, hey, IDK. Didn't take my test until the 22nd of May, so I'm chilling. Good. You need this to retake my test. Awesome, Vaughn. Well, a unit test, not the AP test. Gotcha. Take my AP exam. Okay. What's the point of logarithms? Okay, just doing the inverses. If you do it one way, you gotta do it the other way. All right, seems like I'm all caught up. We got some people that found some friends. That's awesome. All right, so let me unzoom a little bit. And let's make some room. All right, so if I had, where is it? I love when I organize everything and I'm like, where's it going? All right, so I'm gonna call this expanding. So when I have the log, okay, let me write example. So I have the log, I'm gonna write pretty big tonight. So the log base 4, x, y, z. Okay, the log base 4, x, y, z. So first thing, I take a look. X, y, z, that means x times y times z. Because anytime I don't see a plus or minus sign in between variables, that means we're doing multiplication. So right now, everything is kind of condensed together. So that means I need to expand it out. So what I'm going to do is the product rule. Okay, so I'm going to give each of those variables their own log base 4. So here we go. So we got our log base 4 of x. And since it's the product rule, that means we're going to add them together. Okay, just like when we were doing the exponents. When we have our exponents, when we're multiplying, we add the exponents. So right here, we're multiplying. So we're going to add the logs. Now we have our log base 4 y plus our log base 4 z. Okay? What you just did was expand your log. That's all you did. Okay? So once you recognize, am I multiplying these numbers here or variables, or am I dividing those numbers or variables? Okay, so let me try something a little more difficult. Okay. Yeah, I'm not sure, Ben, if I'm going to have time for change of base, but I definitely did change of base last night. So if you go to my YouTube channel, ACG Math Tutoring, and check out the live that I did, because that's on there now. I put it on there early this morning, okay? So if I have, let me change colors so it'll be easy for you guys to follow. So if I have log base 3, and I have 2a over b. Okay, there you go. All right. So now we have our log base 3. But the main star is what's happening right here. We have 2a divided by b. So it looks like a couple things is happening here. Okay? Yeah. Because, is it Martino? We are going to be division, but there's something else happening in here. So when we divide, we are going to do some subtraction. Yep, we are going to do some subtraction. Good, Nicole. But look at this 2a. 2a is what? What operation is 2a? Okay, so it's going to be multiplying, right? Because it's twice a. So we're going to be multiplying. So yes, Martino, we are going to be doing some addition. So let's take it step by step. So the first step, let's give the numerator and the denominator their own log. So we have log base 3, and I'm going to say 2a of 2a minus, and the reason why it's minus, because when I'm dividing, remember that quotient rule right here, when I'm dividing, I'm actually subtracting those logs. So now I have my log base 3 of b. So this log base 3 of b, that's the lowest I can go. Okay, I can't expand that any more of that. But this 2a, that's multiplication. So we want to give the 2 and the a their own log base 3. So we have log base 3, 2, plus, and the reason why it's plus, because we're multiplying the 2 and the a. So when we expand it, it's going to be addition. Log base 3, a. And then I just simply bring down my minus log base 3, b. Okay, yes. So this was a combination of the quotient rule and then the product rule. Yes, Pug. Yes, yes, yes. Okay, and hello, Pug. Pug. Okay. All right. So go ahead and tap. If you're just like, ooh, yes, I needed this. Tap it, share it, okay? So a log is the inverse of an exponential. So this is when we start getting into like Algebra 2. And it's usually around this time of year, people are kind of going into logs and exponential just before they take their state assessments, okay? Oh, thank you. I love those. That's so cute. Okay. So this is going through the properties of logarithms. All right, going through those properties. All right, so go ahead, share the live, tap away, because I'm going to walk you through it step by step. Okay. So if you need those rules again, I'll see if I can get all the rules on here. Okay, go ahead and take a quick snappy shot. Okay. So we got all this, got all that. Okay. All right. All right. Thank you for the love. All right. Let's step it up even more, just a little bit. Okay, just a little bit. Okay, so I'm going to flip to the other side. Give myself some room. So we have log. And I'm just writing really large so y'all can really see it. So log base 2, 8 a squared b to the fifth. Okay, so again, it's really condensed, it's really jam-packed. Aw, just for the last. Yeah. I know it's always nice when, we just take our time and just do some math. Not just all about shortcuts, like actually teaching it. All right. So, taking a look, we have a log base 2, 8a squared b to the fifth. So we got a whole lot of stuff going on here, okay? But let's take it step at a time. So looking in between the 8, the a, and the b's, I don't see any plus signs or minus. So that means I'm doing multiplication here. So if I'm multiplying, what am I going to do with the logs? Put it in the chat. Hey, film artist, how are you? Put it in the chat. Pause, got that. Isolate all variables. Yes, we multiply, we add. Good. Hello, Logan. Hey, Susan. Thank you. Okay, yes, we're going to add. Good, Nicole. Good. Hello, the chocolate unicorn. Okay, so we're going to add those logs. All right, so we're going to give each of these terms, the 8, the a squared, and the b to the fifth, their own log to the base of 2. So we have our log base 2 of 8 plus log base 2 with the a squared plus log base 2 b to the fifth. Now, if I was smart, I would have put it in different colors so you can really see it. Okay. All right, so I'm going to try to separate as best we can. Okay, so we have our log base 2 of 8. That's 1. We have our log base 2 of a squared. And we have our, can't use that color. And we have our log base 2 b to the fifth. Okay. Next time I'll write it in colors. So now, my log base 2 of 8, right now there's nothing that I need to do with that. So we're going to keep that. I mean, yes, there's probably a perfectly good answer, but remember, we're not solving, we're expanding. Okay, so we're not into the solving game. We're into the expansion. We're just going into the store, getting a different outfit, but it's still us that's going to leave the store. Our same personalities, we just got a different look. Okay, so now we got this log base 2a squared. We need to change that. So now I have an exponent. So that's coming back to here, that power rule, okay? Years ago, there was something called Basketball Wives. I don't know if it's even still on. It used to be like a whole bunch of women that were married to ballers. And I will never forget, there was this one girl named Evelyn. And she was married to... he was actually a football player. Oh God, what was his name? It was like Nacho something. He was a football player. And I will never forget that she wanted to fight this other woman. And when she saw red, she saw red. Like she was blacked out. And all of a sudden she just wanted to kill this girl, right? And what she did was she jumped over her friend, over the table, to tackle that girl named Jennifer. So I will always remember, like, this number 2 is like Evelyn. Say Jennifer is right here in front of the log. So Evelyn was like, I'm about to beat the living hell out of this girl. So she jumps over and jumps in front of the log. Don't ask me. These are the little things in life that just sticks in my head, right? So what we're doing is we're moving this exponent to in front of the log. But the a remains, okay? Only the exponent is jumping to the front, right? Yes, ocho cinco. Thank you, Corey. Yes, ocho cinco, right? And if you remember that, like that was like something that was huge. That was before Teresa was like flipping over tables for housewives of New Jersey. So yeah, that was my life before tutoring, right? So what we're doing is we're moving that exponent in front of the log. I always call it the Evelyn rule when I was teaching in the classroom. And it stuck, right? So now, if I look at the next one, the same thing is happening to this log base 2 of b to the 5th, okay? So that means that 5 is coming in front of your log of 2, but we keep the b there. So now what happens is I got to drop the plus sign in between. I got to drop the plus sign in between, and I'm just going to drop my log base 2 of 8. Okay? So now, there's no more exponents. Okay, I got an A, I got an E, I got an 8, an A, and a B. So this is as low as I, could go. All right. No, because we're not solving, Jam. We're only expanding. I know it's really tempting, but we're only expanding. We're not solving. Okay? All right. Now I'll never forget this rule. Not a problem. All right. So let's see if we can get a, let's try this one. So we have log base 4, and we have 16w cubed over x to the 6th. Okay, can we all see it? Sometimes it's really hard for me to see. Make sure that you guys got that. Okay. Well, if you were to solve, it's kind of like, what are you solving for? And if you do need to solve, yes, you would change that. You can do change of base right here, which would be the log of 8 over the log of 2. Or, since we know it's going to be 2 raised to something equals 8, which will give me 3. Right? And I think that's the only thing that could be changed. Everything else will stay the same. Okay. Okay. So there's some other things in there too, Logan, but good. I noticed you noticed the original. Hey, Leah. How are you? Okay. All base 4. Good. Subtraction. Good. All right. So, here we go. So, first thing, let's take care of that quotient. Okay, give them their own log, base 4. Okay, so all we're doing is expanding. So that means we have our log, base 4. Start with the numerator. So like some of you guys were saying, 16w to the 3rd minus log base 4 of x to the 6. Okay, good start, good start. Okay, so we took care of the quotient rule. Now, let's take a look. Right here in the beginning, we have 16 times w to the 3rd power. Okay, so right now, and this is when it gets funky. Because some people will be like, oh, okay, you could put the 3 in front. But here's the thing. What is actually being raised to the 3rd power? What's being actually raised to the 3rd power? I'm going to highlight it so you can see what I'm talking about. What's actually being raised to the 3rd power? Okay, I'm seeing W, I'm seeing W, I'm seeing W and W. Okay, so just the W is being raised to the 3rd power. Okay, only the W. Now, if there was a parenthesis around that 16 and that W, yes, that 3 pops in front. But the whole thing, the 16 is not being raised to the 3rd power, just the W. So that means we need to split this up. Give the 16 its own log to the 4th, and give that W cube its own log to the 4th. So it's going to look like this. You got your log to the 4th of 16. And since it's a product, since it's multiplication, we're going to add. Then we have our log base 4 with W cubed. And then I bring down my minus log base 4 x to the 6th. Okay? And some people will be like, oh, could you just? Yes, I could. But remember, I like to take things step by step so we can have a good idea of where things are coming from. And if you feel like you're a little lost in the sauce, let me know. Let me throw you a lifesaver. Okay. So how do you know it's a subtraction sign? Because when let me slide this down a little bit. When we were dividing, remember, if I was thinking of exponents, if I'm dividing, I subtract the exponents. Same thing is happening here with logs. So we had to split my numerator and denominator with that subtraction. Anytime you're dividing, you're subtracting. Anytime you're multiplying, you're adding. Okay? All right. Good. Way to help each other out. Love it. Love it. All right. So now, I know you're going to be tempted to tell me, oh, Audrey, it's 2 right there. Remember, we're not solving. We're just expanding. Okay? I know. It's so crazy. So it looks like this log base 4 of 16 is going to stay exactly the same. Got our plus sign. But what's happening here? Hold on. Let's see if I can cover up just a little bit. Because I know some people get very overwhelmed when you look at the whole thing. So just give me one moment. Okay. So now, taking a look right here. Okay. So that log base 4 w to the 3rd. All right. That is going to be that power rule. Okay. Is this for Hillman Talk? No, I'm not a part of Hillman Talk. They didn't want me. That's okay. All right, so we got that 3. Got that cube. So that means we're dealing with Evelyn. Go get Jennifer, Evelyn. Okay, so we have our 3. Then we have our log base 4 W. Okay, so anytime we have the exponent, that's when it jumps in front. And then you bring down your log base 4 and keep the W back there. Okay. All right. So now we take a look here. So we got our log base 4 of x raised to the 6. So that means we got another Evelyn. I don't know why everyone keeps pissing off Evelyn, knowing that she's real. She is real about that life. Okay? She's getting better, though. I don't even know if the show's still on. Because it started getting crazy when it was like, what was it? They were out in LA, and I'm like, ugh, why? What are you doing? All right? So the 6 is jumping in front of the log. And then we have to bring this minus sign back. Okay, so we don't have any exponents. Okay, we're not, I know it's tempting because I'm looking at it like, oh, I gotta do that. No, you do not. So this is your expansion. Okay. Okay. What about the x? What about the x? What about the x? Oh, I did miss the x. Thank you. I was like, what x? Yeah, that x does go back there. Let me just erase that and sneak that x. Thank you. It has been a day. I'm surprised I'm functioning right now. All right. Okay. Thank you all. Yes. Hey, Tamika. Yeah, I forgot the X. I love it. Everyone's like, what happened to the X? The X! The X! No! Okay, I'm actually going to do a root. How'd you know? Reading my brain. Jerry. All right. Oh, where's Michael? Haven't seen him today. All right, it's okay. We will cross paths. Okay, so now let's give this one a try. So if I do, I think I don't have to use so much space. So if I have the log of square root of r, you're like, ooh, wait, oh. Are you helping with people's homework? Right now, I'm just taking what I started with the exponential and logs yesterday, and I did promise that I was going to come on here and talk about expansion and condensation. Trust me, I really wanted to go to bed. Nope, it doesn't look complicated. It's okay. Breathe. Everybody's freaking out. Oh my God, this is spirit. Breathe. We got this. No worries. Now, square roots, I can actually change to an exponent. Now, the ruling for that is you have your degree. I think you guys can see that. Okay. It's called your degree over the root. Now, the degree is what is r being raised to underneath the square root. If you don't see a number, it's assumed to be a 1 as the exponent. The root is what type of root is this? And most times you'll see a number here. If you don't see a number, it's assumed to be a square root because people, there is no such thing as a one root. You could try, but no. All right. The lowest that you can go with roots or radicals is a square root. Sometimes you may see a 3 here, so that would be a cube root. Sometimes you can see a 4 here. That pops up once in a while, and that's called a fourth root. I know, it's so deep, right? So if I want to, I can change this radical into an exponent. This is how I'm going to do it. So we're going to keep the log on the outside. So remember, it's your degree over your root. So we're going to have our r. The degree, we didn't see anything, so it's a 1. And the root is what type of root it is? It's a square root. So this is r raised to the 1/2. If it's raised to the 1/2, it translates into a square root. Okay, I'm going to look at the comments every time I see something. Okay, so a couple people jumping ahead, which is awesome. Oh, wait, hold on. Yellow chicken looks complicated. If you break it down, it becomes easier. I did organic chemistry problems harder. Okay. All right, how does 1/2 turn to a square root? Okay, so Jerry, do you see how it became into a square root? Use this in real life? Yo, I don't know what you want to do in your real life, bruh. I don't. You know? So my whole thing is like, I don't know if you want to be an engineer. I don't know if you want to do any kind of like measurements with geometric sets. I don't know what you want to do. Okay? I don't know if you want to see if you can make an arch in your, an archway in your, what's it called? Door jamb. Okay? Instead of just the traditional doors. I don't know. But if you do, this can help you make that arrangement. Root, it will be one of, yep. If it was a cube root, yep, it will be, the exponent will be 1/3. That's correct. I know, right? Well, of course, if you're not going to the grocery store. But here's my thing. I rather, and I say this to all my students, I don't know what you're going to want to do in life. And we all know, teenagers, I love you dearly, but you guys change your mind every 2.2 seconds on what you want to do. 1 minute, I want to be an astronaut. Next minute, no. I want to be a rapper. Then all of a sudden, look, I want to be a rapping astronaut. Then all of a sudden, you're like, you know what? I think I might want to be a teacher. Nah, they don't make no much money. I want to be a doctor. You keep changing your minds every 2.2 seconds. So I'd rather, if you ever come across in any kind of math class, I'd rather you say, I've seen this before versus what the hell is that? Okay? So that's why I do all these things and I break all these things down. Okay, so I'm not doing linear algebra problems. Sorry, I'm just doing my logs right now. So if it was a 4, it'll be a log square root of 1/4. Yes, if it was a fourth root, yes. I missed that lesson. I know logs already. Okay, good. Well, I'm just doing logs, Chris, so I'm so sorry. Okay. All right. Now, knowing this information, I know a couple of you guys already put the answer down a long time ago, but we got to break stuff down to people, okay? So now, if we take a look, we have an exponent, okay? We don't have anything to multiply by, but we do have an exponent. So, guess what we're doing? We're doing an Evelyn. So we're going to take this 1/2 and put it in front of my log. So we have 1/2 log r. Now notice I didn't say a base. What should my base be? If I don't see anything, what's assumed to be there? Yes, look at my intelligence. Hey, John. Okay, so it's going to be tens, tens, tens. Okay, for a log, this is called a common log. The base of a common log is 10. The base of a natural log, which is our ln, the base of a natural log is e. Okay, so this is done. Okay, not too murderous. Okay, all right, nice, good. All right, so let's try one more before I take it the other way, which is the condensing. So if you know it one way, you have to know it the other way. Okay? I know. You're like, no, Audrey, don't do it. Yeah, I'm going to do it. All right, so if I have, think about an even amount. So let's try this. Let's see if you guys can still see that. Okay. So we have log base 3 of 9v cubed over u squared. And I'm going to do it like this. Okay. And actually, I'm going to slide my whole apparatus down because all of a sudden I notice I'm like on the edge of the table. I don't have a huge desk, but it just cracks me up. All of a sudden I'm like, wait, why am I on the edge of the table? It's like math's got me all excited. Okay. Okay, so fufu is great. Okay, I know you just got here. So I'm not expecting you to be like, oh, I know this. And, it's okay. Okay. All right. So we're taking it step by step. So just hang on because I'm going to go through it momentarily. Okay. Okay. So Leah and John, you guys can both take it one step further. Okay. And if you're done, go ahead and tap the screen. And if anyone you know that will appreciate this, can use this as some help, go ahead and share the live for them. I mean, math is very interesting. That's the one thing that was not always intriguing to me, because I'm not going to sit here and lie and say, yeah, I was a great math student. I used to suck at math. I am not even going to sit here and try to lie. I was terrible. If I saw a fraction, nope. I saw a word problem, oh, hell no. I wasn't doing it. Like, it was just, it took for me at the rightful age of 25, and I was working as an instructional assistant with special ed kids at a high school. And the teacher just said, dividing is nothing, fractions is nothing but division. And just for her making that one statement, for some reason clicked. And I remember I said at the rightful age of 25, right? Then slowly but surely started breaking down concepts. Okay, slowly but surely started breaking down. Oh, thank you. Yeah, 10K will be amazing, guys. Don't hold back on your likes, love. All right, and it's true. So it's master in this, right? So sometimes it takes time. It does take time. The exponent is throwing you off. Okay. Think about what we do with the exponents. Don't forget about Evelyn. Okay. All right. Okay, let's type it up. Let's see if we can get to like 7K. There's 31 people in here. If we can get to 7K, then I can go to the next step. Quick taps, mad taps. Tappity tap tap. Oh, good. Yeah, calculus, it's like a love-hate relationship. But it's like once you understand what the movement is, and then you understand how some formulas are very much the same, it's just like a different name, or they just use a different Greek letter to represent it. You're like, oh, this is just slope. It's just so funny how it all kind of plays on this stuff. All right. Okay. Thank you so much, guys. Keep it going. All right. I am going to break it down. You guys can keep tapping. All right. So, first things first. We have this division. Anytime we have division, just like if I was dealing with exponents, I would subtract the exponents. You're doing the same thing with the logs. So, I'm going to have my log base 3, and I'm going to give my 9v to the third power minus my log base 3 of u squared. Now, we're taking a look at this first one. Since that 9v is inside the parenthesis, that means both the 9 and the v is being raised to the third power. So I can go right into my Evelyn. Okay, so I have my 3 with my log base 3 of 9v minus, and I can do the same thing with this too. Do the Evelyn. Anytime I have an exponent, it jumps right over the table. Superman Snooker. Okay. But this is where some of you guys stopped. Take a look in here. Okay. We still have 9v. 9v means 9 times v. Okay, so we can break that down. So when we're multiplying, we're actually going to add, just like with exponents. If we multiply with the same base, we add the exponents. Okay, so we're going to give each of them their own log. Okay, we're giving them their own entire log. So the 3 is still going to stay outside. Okay, still going to stay outside. But this time, I'm going to put a parenthesis. The reason why I have my log base 3 for the 9 plus my log base 3 for the v. Because remember, this was my exponent for both the 9 and the v. Okay, so that's why I'm putting parentheses around this, because if I were to condense it, I would multiply the 9 and the v, and then the 3 will cover both 9v. Bring down my minus, and my 2 times the log base 3 of u. Okay, that was the one thing that some people that answered earlier was missing. Okay, and let me take a look at my comments, see how we're doing. Hey, Lynette, thank you. Yes. Yeah, I'm starting to learn about that daily heart. So check in if you do have that daily heart. That would be awesome. Okay, how are we feeling? How are we feeling? It's being cute. Can't you simplify that? No! Oh yeah, Matthew, you weren't here earlier. We're just expanding. We're not solving. Okay, we're not solving. So we don't want this to be a 2 yet. We're not solving. We're just expanding. Okay. Hey, Lisa. Okay, so we're just expanding. Okay. All right. So that is doing with the expansion. Okay. Because 9 times v, we can't have a product. This has to be that product rule. Okay. So if we go to the product rule, anytime we're multiplying, remember this 2x, okay? That means we have to give 2 has to have its own log base 5, as well as the x has to have its own log base 5. Okay, so that's why you separate. So you want to simplify as low as you can. Okay, not a problem. All right. Okay. Actually, there was one problem that I saw. I was like, ooh, I wish I could have done that one. All right, so I'm going to leave you alone with this extra problem. Bonus. There's a bonus problem. Yes, there is. All right. So I want you to try this one. So we got log. And we have the 5th root of x squared. Okay. But with equations, okay, good. No. Yes. Expanding. We're expanding it. Let me tilt it so it won't be so cockeyed. Yep. Yes, it is log base 10. Good. Keep going. Oh, I feel like a proud mama right now. Okay, good. Okay. It's too hard? Oh, Lana, we're going to take it step by step. Okay? Okay? Take it step by step. There you go. Nicole, very close. You're missing something. What are you missing? Okay. All right. Okay. So, remember, who is this? Dolores, for your exponent, use this. Your degree over root. Okay, so it'll be degree over root. So now, we still have our log with a base of 10. Good, because it's a common log. We have our x. Now, my degree. The degree is the exponent underneath the radical, so that's 2. So is my degree over my root. The type of root has the index right there. Okay, so degree root. Easiest way for me to remember is degree. I think of heat. When heat rises, that's going to be on top. Root, I think of the roots of a tree. Where's the roots of a tree? Any kind of roots is usually underground. So that's their denominator. Heat, tree. I know, the weird things that comes to my mind. All right. So now, since it is an exponent, Evelyn, go out to Jennifer. Okay. So that gives us our 2/5 log of x. Okay. Nicely done, ladies and gentlemen. Okay, that was the only thing that was missing. There you go. Okay, they make sense. There it is. All right. So, that was us expanding. Okay? Now it's just like me. My weight is expanding. Now, I gotta worry about condensing. Gotta put myself on a diet, you know? Gotta lose a little bit of those winter pounds. I think everyone says that. All right. So now we're going to look at the condensing. So I'm going to say right here. All right. Oh, what is today? Wait, is it still today? Okay, it's the 9th. So I'm going with 4/9. Like, it's like the days are going crazy. I'm almost done with making all my copies of my notes. I'm going to try to even sell copies of my notes so you can use it almost like as answer keys, as Michael would say, for when you're watching the lives on my YouTube channel. So they'll be coming out soon. My friend Lynette likes to call them Audrey's notes. Just like there's Cliff Notes, then there's Audrey's notes, right? So the same coloring, same all that. Oh wait, today's not the 9th. Today's the 8th. Okay. All right. So now we're going to keep those rules in mind. Okay. So here's a fresh look. If you need to take a quick snapshot of it, do it now. You got 5, 4, 3, 2, 1. Awesome. So we got our product rule, our quotient rule, and our power rule. So we're going to keep those in mind as we're going to condense our logs. So let's go by example. So let's say we have 3 log of 4 minus 2 log of k. Okay. So what we're going to do is in reverse. Michael, you're here. Quietly listening. Go ahead, tell what it is. It's stalking. No, I'm just kidding. So I'm glad to hear you. Glad to see you're all right. All right. Now, the degree in the root tree. Yeah. Yes. So now we're going to do this in reverse. The first thing I like to do is almost like when you see an instant replay. So we are basically sending Evelyn back to her seat. Okay? We're not doing it once, but we're doing it twice. So anytime you have a coefficient, that's really your exponent of your result. Okay? So if it looks, it's going to look something like this. So you have your log of 4 raised to the third power minus log of k raised to the second power. Okay? Now, taking a look, we got a minus sign. We have the same logs, and they both have the same bases. There's a common log with a base of 10. But now we have this subtraction. So that's telling me I'm going to divide. So since we have the same log, I'll write that log out. But I'm going to write the first number as my numerator. So that's going to be 4 cubed. And it's going to be over k squared. And this is my answer. That is condensed. Okay? That's condensed. All right. Talk to me. Let's see if we can zoom in a little bit more. Okay. Talk to me. All right. So now, remember, okay, we're just condensing. We're not solving. We're not changing anything right now. We're just condensing. Okay? So the 3 is the exponent of 4. The 2 is the exponent of k. So that's where you got your log 4 to the third minus log k squared. Since it's minus, that means we're dividing. Okay? So we're doing the opposite of the quotient rule. So we still have that log. We have that 4 cubed. That's the numerator. The k squared, that's the denominator. All right. I feel like I'm not getting... Oh, here we go. Okay, what happened to the 2? The 2's here. It's really small. Okay, never mind. Gotcha. All right. Okay. Sorry, my computer wasn't hitting all of the things. Okay, so let's try another one. So let's say we have let's say, yeah, we could say this one. Let's go with log base 2 of 8 plus 3 log 2 of x minus log base 2 square root of y. What? What is she saying? What is this gibberish? Let's see. I think we can see it that way. There we go. In the comments. I mean, like, Danny Boy, real facts. Real facts. I'm surprised people don't try to do that. You know? Because a lot of people, when they do go live, you know, they can go ahead. And do log 3 square root of that square. I'll see what I can do, Manny. All right. So you're saying power, product, and quotient rule. Okay. I was like, actually, that is pretty smart. Oh, we're just doing this. So what do you guys think? Yeah, but here's the other thing, Danny. When you do that, sometimes you got those trolls that will act like they are doing something, and all of a sudden they screw all your homework up. So you got to make sure that you understand what it really is supposed to be before you do anything. What to do with the square root? Ooh. Let's go. Let's give it a try. All right. So the first part, we have log base 2 of 8 plus 3 log base 2 of x minus log base 2 square root of y. Well, I know, since I see this plus sign, that these two things are going to be multiplied together. And then I know that whatever I get from that, it's going to be subtraction with that last part. But we got a reverse of an Evelyn. Okay, so that 3 is going to be the exponent for my x. Okay, we don't, so I always like to see, do I have any leading coefficients to make into exponents? That's my first step. If I do, make them into exponents. So now we have the log base 2 of 8 plus, put it here, log base 2 of x cubed. Then I have minus log base 2 square root of y. So I don't have to convert the square root of y because I'm not going to take that exponent and put it in front. Because I'm condensing, okay? I'm not expanding. I'm going to condense. So I know, and sometimes some of the rules that we're used to, it's kind of hard to break. So now this part here I'm going to condense that. So since it's a plus, that means I'm multiplying my numbers. I'm multiplying the 8 with the x cubed. So I got my log base 2 is going to be 8x cubed. Then I bring down my minus log base 2 square root of y. Okay. Right. Okay. Okay. So now, I mean, you can. You can, if you want to change that to a y, you can. But remember, it's not going to go in front of your log because you're not expanding, you're condensing. So if you don't want to leave a radical in your denominator, you can change that to a fraction as an exponent, if that's what you feel like doing. Because remember, most places will accept both, even if there is a radical in the denominator. So remember, the degree is what's next to as an exponent for the y, and the root is what kind of root it is. So heat is 1, tree, it's a square root, so it'll be 2. So if you want your log base 2, 8x cubed, now we have the same logs, and since it's subtraction, that means we're dealing with division. So you write your log base 2. Your numerator is going to be the first, which is my 8x cubed, over my denominator, which will be my y raised to the 1/2. And you can leave your answer just like this. And depending on testing, you might see it as a 1/2. Some places actually will keep it as a square root. So there are options, okay? It depends on the test. Okay. All right. So even if you kept it with the square root of y in the denominator, that's fine as well. Okay. Okay. Yep. All right. How are we feeling? You're basically learning like almost like 2 days of math in like less than an hour. So you guys are doing fabulous. Not to toot your own horn, but toot toot. All right. Let me see. Let me see if I can. So you have log 3 square root. Trying to find where that person had. I think it was Manny. Of x plus y. Manny, are you still here? Okay. Oh, that'll be nice, guys. 20K, that'll be awesome. Thank you. All right. So my fave, okay, just got done learning about this. Yeah, my class, yep. Those kids messing me up. Maybe I'm mixing expansion. Yes. Only doing expanding condenser right now. Yes, we are. Just those two. Okay. So right now we already did the condensing. Now we did the expanding. Now we're doing the condensing. Okay. So yeah, definitely have to get those rules, okay, down packed. You have to get these rules down packed. Okay, so think about it. If you're multiplying with exponents, you add the exponents. So if you're multiplying with the bases, you're adding the exponents. So that's your product rule. You're doing the same thing with logs. When you divide, you subtract the exponents. You're doing the same thing with log. You're subtracting. And then when you have a power raised to a power, in this case, if it is an exponent, it becomes your leading coefficient. Okay? I like to call it the Evelyn rule. Okay. Yes. Okay, cool. It's like, I appreciate you teaching it. All right. So now, let's see. How hard do I want to make this? How about very hard? All right, so I'm going to try this one. Just see what you can do. Okay, just to see what you can do. I'm just curious to see what you can do. Just curious. Waiting for someone like, I'm out. Okay. It's okay. All right. Okay. All right. All right. Thank you for the love, guys. Appreciate it. Love the encouragement. There you go, Danny boy. Love that. Okay. Okay. All right. Oh, there is one. I knew I made a mistake. There's one mistake right here. That last term, that's supposed to be a plus sign. My fault. I'm starting to get sleepy. I'm sorry. I'm starting to get sleepy. This is supposed to be a plus sign. So sorry. I'm surprised I held it together this long. To be honest with you. Got a total of 3 hours sleep. So Audrey will be going to bed soon. Okay, does that help out a little bit? Yes, the same, Michael, the same rules do apply for the natural log. Same as the common log. So they do apply. Okay. I'm seeing a no. Hey, Amber. That's all right. Trust me. It's perfectly fine. It was a long day, but it was productive. It was very productive. Helping a lot of students from around the globe. But I just got word that Trump is taking away student visas away from Johns Hopkins, UMBC, and University of Maryland. So anyone that's here on a student visa, he's denying them. So weird. I don't know. This world's going crazy. But anyway. All right. Interesting session. The album. I know, right? I'm telling you, you will never unsee it. You will never unsee it. I used to actually show that clip so people will know what I was talking about, because some people don't watch that. My little guilty pleasure. Now it's like 90 Day Fiance. Like, why do I watch these things? Why? All right, so taking a look. First thing, I always ask myself, do I have a coefficient that needs to be an exponent? And here she is, Miss America. So that 4 is now going to be an exponent. Okay, so we have the natural log of 3m plus 5. Okay, it's that whole expression minus the natural log of m to the 4th plus the natural log of m minus 1. Okay? So, and you're probably thinking, all right, Audrey, well, there's subtraction, so I know there's some division going on, and then there's some multiplication. So which should I do first? Well, my loves, don't forget, please excuse my dear Aunt Sally from left to right. Okay? There's nothing to combine inside the parentheses. We already took care of our exponent. So now we always do multiplication before division. And I know it says from left to right, but do the multiplication before the division when it comes to logs, okay? It will make your life so much easier, all right? So if we do this, what we will get is we have that natural log. Okay, so we have that natural log. And since it's addition, we're going to multiply those. So it will be m to the fourth times m minus 1. Then we bring down our natural log, 3m plus 5. Okay, so trust me, do the multiplication before you do the division. It will make your life so much easier, because then you won't get so lost in the sauce. All right, let me check. Okay. Okay, Nicole, what's wrong? Okay. Well, the fact that you're sticking to this for this long, Nicole, that's awesome. Come on now. Pick that head up. Pick that head up. Okay? It's okay. Because really, this is getting into like some advanced placement stuff. And sometimes it gets a little bit much. Like I said, this is usually like a 2, maybe 3-day lesson. Okay? When I was in the classroom. Because just to give people time for them to understand what's happening. Okay? And you're learning it in about an hour. Like, what are you doing? All right? So now we have the same natural log. We'll have the numerator, which is, I got to put it this way. I ran out of room. 3m plus 5 over m to the fourth, m minus 1. That's our answer. Okay. Okay, don't know where to start. Okay. So when you see these, the first thing, look to see. And you already said this. I saw it in the chat where you say, okay, I know I need to put the 4 as an exponent. That's step number 1. Then step number 2, because I screwed up, this was supposed to be a plus sign. Do the things that's representing multiplication next. So that means you have the same natural log, and then you're multiplying these two because it was a plus sign. So it'll be m to the fourth times m minus 1. Bring down the other one. Now there's a subtraction. That means we're going to do division. We have the same natural log. Boom. We start with from the left to the right. So the left, that 3m plus 5, that's going to be my numerator. And then the other m to the fourth times m minus 1, that's my denominator. And then we're done. Okay. Okay. Yep. See, my thing is, these concepts, you got to understand, math is constantly reverting back. So there's Algebra 2, pre-calculus, college algebra. Some places have what's called integrated topics. Some people have it for, intermediate math, because it all happens at different spots. But this, I'm telling you, math, it's not a one and done thing. It always spirals. It's a natural spiral. You always spiral back to it. Okay? So that's why when someone asks what grade this is, I'm like, I can't answer that because I don't know if you're honors or general or, I don't know. I don't know if you're in advanced, like GT Algebra 2, or you're in AP Pre-Calculus or AP Calculus, AP and PC and all the letters of the alphabet. So all I know is it's definitely advanced math, okay? It's definitely more than Algebra 1, that's for sure. So it's getting yourself into more of like late Algebra 2 or early pre-calculus or midway college algebra. Okay? All right. Any inverse, not subtracting. Okay. Should n to the fourth be distributed? No. No. Because what we're doing, Olivia, we're not solving. We're actually condensing. I know, it's so tempting. It's so tempting. But all we're doing is condensing the problem into a more compact form. Okay? I want to be super smart. I'm like, you are super smart. Okay, cool. It's usually considered college algebra for what I experienced. Yes, but here's the thing, Danny boy. Everything is picking up. Everything is picking up. Ever since the pandemic, they have increased the curriculum throughout. I know from my state of Maryland, and especially Florida, I know, California, I know, Texas, Alaska, like throughout all my tutoring areas, they have picked up the pace easily, like ×2 since the pandemic. So you would think, pandemic, okay, let's make sure we understand these concepts before we move to the next part. No, it's like business as usual. And then you have teachers who are like, you should know how to do this. There's something called a pandemic. And I had a teacher that was like, hey, let's watch Netflix together. Or I had some teachers that were just like, I'm not going to go too deep into stuff because I don't know how to use Google Classroom. Like, we as teachers, we had to learn how to do this stuff on the fly. We had very little instruction. And trust me, it was hell if over. It was absolute hell. Yeah. Everything. Not a problem. So, like, don't even think that you can't do things. You can. It's just, I think someone mentioned it earlier. If you can get a teacher that is willing to break concepts down into the way, like, think of my degree, the heat in the tree, for you to understand going from a radical to an exponential. Little phrases and things like that seems to always be somewhat helpful. All right. Okay. I think that's enough. Because I'm about to go delusional. My goodness, guys. 22.5K. Man, you guys been tapping like there's no tomorrow. Probably have a cramp. All right, so hopefully, I know some of you guys said that this was helpful, but hopefully you guys understand, like, these concepts, okay? This is just a little bit of like a shortcut if you ever have to simplify. But these rules right here, crucial, okay? So if you notice there's a plus sign, that means you had to multiply your results, okay? If you notice there was a minus sign, that means you got division in your quest. And then if you ever have an exponent, don't forget about Evelyn, okay? All right, so if she's already up there, she comes to the front. If she's already in the front, we got to put her right back, okay? All right. Not a problem. Okay, Tamika. Hopefully this helps for your next section. Let me know. Gain the follower. Oh, thanks, Danny. I appreciate that. Be going over this tomorrow around this time. I have a test on Thursday. Well, why don't you hire me as a tutor? Everybody. Feel so much comfortable for my test on Monday. Okay, not a problem. Because what am I doing tomorrow? Tomorrow I wasn't doing any more tomorrow I had to do surface area and volume. Okay, cool. They're really fun. They are fun, Nathan. They are really fun. Okay. You do trig too? Yeah, I actually did some trig. Take a look, and if you're not sure, guys, take a look. Go onto my YouTube channel. Go ahead and subscribe. Go ahead, it's free. Like, come on. I try to put all my lives on there. I started going live early February, so I have basically tons of lives on there. You can fast forward, you can rewind. There's a couple shorts that I put on there, and double check because I know I did some trig. And just like the basic trigs so far, the sun, Sokotoa, like what were you thinking of? Ashley. I think it was Ashley. Was it Ashley? And Danny Boy. Okay, so yeah, definitely take a look at my YouTube channel. And I feel like I've been doing trig for a minute. And I know I was doing with the focus. What did I do today? Today was the focus and the directrix. Focus, directrix, and finding the vertex and axis of symmetry. So that's what I was doing today in the tutoring session. Just based on the time you took to tutor me. Aww, thanks, Boo. Appreciate that. Hopefully things are going well. Also, follow each other. I mean, heck, you guys talk to each other all the time. Go ahead and follow each other. This is like another way to pick your pace up. I think someone did mention to start their own. I think it was Danny Boy. Seriously, start your own and see if people can help you with your homework. I'll bet you cold hard cash there's going to be people that pop in that always want to put their 2 cents in and help you break down concepts. Shoot, why not? Hey, as long as TikTok is around, ride it till the wheels fall off, right? All right, so I will see you guys again. If you like the notebooks, eventually what I'm going to do is I'm going to have all my notes is going to be for sale. Copies of it, of course, will be for sale. But if you want to have your own notebook to kind of help organize yourself, I know it's close to the end of the school year, but keep it in mind for next year. See, I did some Pythagorean theorem stuff. And I did do some trig functions, so I remember doing some stuff, right? I was like, yeah. We started with the little intro to Sokotoa. Had a couple word problems, looking at the angles, elevation. We also did special triangles. And I did completing the square and that. So if there's something else in trig that needs to be deeper than this, I think that's as far as I got with trig in here. Yeah, and I have to work on those rational functions. Okay? Yeah, so tomorrow I think I am doing surface area because I do have to do some more geometry because surface area and volume is huge. Now, if you're unsure about your multiplication, I have factor sheets. Okay, all the factors from 1 all the way to 200 is in here, as well as the rules of integers, also the order of operations. Okay, we got our properties of exponents. I'm going to actually put the logs in here for the next couple ones. We got our lines. We got some things for transformation. Also properties of quadrilaterals. This I use a lot of. Then I have my trig stuff. My reference pages. If we're looking at surface area and volume, I have the formulas for that. As well as when you guys get a little bit more advanced, oh, the unit circle, everyone's favorite. All right. So with that, also I have like little puzzles in the back for the brain breaks. Everybody just needs like a place just to kind of debrief and just, do some mindless stuff to help actually refocus. So I have it in sale on Amazon. You can go to my profile and go to my website, ACG Math Tutoring, and you will actually see a page where it says the Ultimate Math Notebook, and you can purchase yours today. All right, so shameless plug, Google reviews. I really would love to get 100 before the school year is over. I am not too far away from that. But let's see if I can get up my subscribers. And as well, I would say this is my new live schedule. My schedule is all over the place because every time I turn around, I got a new student. And there's only so much of me that can go around. But it looks like tomorrow I'll be able to come on about 8:30 because I do not have someone at 8 o'clock. They canceled. So I will be coming on like around 8:30, 9 o'clock p.m. Eastern Standard Time tomorrow. All right. So I won't be here in the afternoon. I think the next time I can go in the afternoon was probably Thursday, but definitely Friday. I'll be here for the afternoon. All right. Thank you all for being here. Yes, PM. Yes. Yes, PM. All right. All right. So I will see you guys tomorrow, 8:30, maybe 9 p.m. tomorrow. And we're going to be working on surface area. I'm going to try to look at prisms, and I actually have it somewhere around here. It's so crazy when it's like you got everything in here. Almost running out of room. Here we go. A little sneak peek. Yeah, so we're going to be looking at volume of rectangle and surface area of rectangular prisms, triangular prisms, as well as cylinders. We're going to see if we can get to cylinders, but that's the goal because that is definitely in a lot of GEDs, ACTs, SATs, all of the T's when it comes to testing. All right. Okay, guys, have a lovely night, and I will see you again. You could probably check out my friend Learning with Lynette. She does abacus. If you want to learn how to do math using the abacus, she is awesome. I'm not sure if Impact Math 19 is available, but she's awesome as a good resource as well. Especially if you're trying to get your ASVAB, your GED, or even help with your TEAS test if you're trying to get into nursing. And another person that would be good to follow, a Blessed RN. If you're trying to become a nurse, she is amazing. She has a way for you to do the calculations of dosage without so much math. You know, it's basically lots of proportions. And if you are struggling with chemistry, Professor TK, she is awesome. I just tried to bond with as many great people as possible. Okay, so if you want individual tutoring sessions with me, please do not hesitate to go to my profile, click on my website, and just type in the information, and then we'll take it from there. All right, okay? If you need me, do not hesitate. Just message, okay? It's okay. Just message. Don't think, oh, I might be bothering her. What am I bothering, okay? God put me on this planet to serve, and that's what I'm doing. All right? So I will catch you guys on the flip. Have a lovely night or morning. And Michael, thanks for coming in. My day is complete. All right. Have a good one, guys. Good night.